So this video is about rational expressions. So first we'll talk about what are rational expressions. So it's where you have a polynomial divided by a polynomial. So let's say p of x over q of x, where p of x and q of x are polynomials and they can be polynomials of any degree. Okay, so some examples. I could have something like 3x squared minus 2 over 5x, or 2x plus 1 over 3x minus 5. Something like that. So those are some examples of rational expressions. And then also they're rational expressions, not equations. So for expressions, we can't solve for the variable. So what we want to focus on is simplifying and getting the expression down to its simplest form. So you will have to know how to factor and also how to make common denominators. So if you need to go back and watch videos on factoring or fractions with common denominators, make sure you do that. Okay, so let's talk about non-permissible values next. So with rational expressions, I do have something called non-permissible values. So because I have a polynomial divided by a polynomial, I remember that I can't ever divide by a 0. So if there are any numbers that, or any solutions to the variable, what do I want to say here? If there are any numbers that make the denominator 0, you can't have those. So those are your non-permissible values. That's what I want to say. So for example, let's say we have this rational expression, so x plus 5 over 7x minus 5 and x plus 4. So to list my non-permissible values, what I want to look at is just the denominator, and I want to think, well, what values of x would make the denominator 0? So again, this goes back to factoring. So if I just quickly look at that here, so in the first set of brackets, 7x minus 5, if x were equal to 5 over 7, that would make the whole denominator 0, so I know x can't be 5 over 7. And then from the second set of brackets, I have x plus 4, so I know in there that x could not be negative 4 because that would make that 0, and 0 times whatever would give you 0 on the bottom. So these would be my non-permissible values. Okay, so this rational expression is good as long as your values of x are not those. Okay, let's see some examples with adding and subtracting rational expressions in order to simplify them. Okay, so if I want to bring together two rational expressions by adding or subtracting, what I need to remember to do is make a common denominator. So because they're fractions, I still need to make a common denominator, and it works exactly the same way as when we had just constants before, but now we have these variable expressions, and that's okay. We just have to take that into account. So what I do first when I'm simplifying rational expressions is I want to come up with what would be my common denominator. So usually the easiest way for that to find that is to just multiply your two denominators together. So here I have n minus 5 and n plus 8. So my common denominator then would be n minus 5 times n plus 8. Okay, and I'm just going to leave it in its factored form. And then to figure out what I would put for the numerator, so what I do here is I look at the numerator of the first fraction, so that was 3, and then I want to multiply it by whatever was missing from its original denominator, which is now in the new common denominator. So the 3 was over n minus 5, and that appears in my common denominator, but then it's missing this n plus 8 term. So I have to multiply the 3 by n plus 8. Okay, and then same idea for the other fraction. So the 6 was over n plus 8, so it was missing the n minus 5. So I have plus 6 times n minus 5. Okay, and to finish simplifying, I have to distribute this constant through the brackets there, and then I'm going to collect my like terms. So I have 3n plus 24 plus 6n minus 30 all over, that should be a 5, n minus 5 times n plus 8. Okay, and then I collect my like terms, so I have 9n minus 6 over, still the same common denominator, n minus 5, n plus 8. Okay, and then I should look again, can I factor anything from the numerator? I can. I can factor out a common term of 3, so I have 3 times 3n minus 2 all over n minus 5 and n plus 8. Okay, and I should also list my non-permissible values. So when I'm doing that, what I should do is I should go back to my original expression that I had, which is here, or where I made the common denominator before, in case I canceled anything when I was simplifying it out, so that I don't miss any non-permissible values. So here my non-permissible values would be 5, because that would make this equal to 0 if I put n as 5, and also negative 8. So if n was 5 or negative 8, it wouldn't work because I'd be dividing by a 0. Okay, let's see another example. So this one I have 7 over 3 minus 8 over 3x minus 6. So the first thing I want to do is I want to factor. So always, when you're simplifying rational expressions, always think factoring. Or in any case, whenever you see any polynomials, the best thing to do is to factor. So I see that I can factor in this 3x minus 6, so I'll leave 7 over 3 the same. And then I have minus 8 over, factor out of 3 times x minus 2. Okay, so now I'm subtracting these two expressions, so I have to make a common denominator again to bring them together. So when I'm making my common denominator, remember I said it's easiest just to multiply the denominators together in order to get the common one. That would give you a common denominator for sure, but it's probably best to find the least common denominator so that you have less reducing to do in the end. So to do that with rational expressions, what you want to do is look for things in the denominator that are different. So I have a 3 in both my denominators, and then I have an x minus 2. So my common denominator, my lowest common denominator, is going to be comprised of one of those 3's. I don't need to take both of them because they're common already in both of the rational expressions above. And then I have to take that x minus 2 as well. Okay, so kind of take one of everything from the denominator and put it in your common denominator. So now when I'm making adjustments to my numerators to keep everything equivalent, I have 7 over 3, so that was missing the x minus 2. So I'll have to have 7 times x minus 2, and then minus 8, and it was over 3 times x minus 2, which is my common denominator, so it wasn't missing anything, so that's it. It'll just be minus 8. So now again, I have to distribute the 7 through, so I have 7x minus 14 minus 8 all over 3 times x minus 2. Okay, so that'll be equal to, collecting like terms, I have 7x minus 22 over 3 times x minus 2. Okay, and then again, my non-permissible values, so x could not be equal to, if I go back up to my original expression here, or I can go to where I factored it, so as long as it's before I canceled anything out. Then I see here the only non-permissible value I have for x is 2, so x cannot be 2. Okay, and one more example. Okay, so this one looks a little bit messier. There's a lot more factoring to do. So again, what I want to do is start off by factoring everything that I can. So in the numerator of the first fraction, I can factor out a 5. So I have 5 times n plus 1. And then in the denominator, I can also factor out a 5. And I'm left with n squared minus 7n plus 7n minus 8. And then in the second fraction, I can't change anything, or can't factor anything out, so I'm just going to leave it like that. Okay, and then right away in the left-hand side here, I see that I can, or in the left-hand rational expression, I see that I can cancel out the 5's, because I have 5 times something on the top and then 5 times something on the bottom. So those 5's will cancel each other out, so I can get rid of that. Okay, and then I can factor this in the denominator a little bit more as well. I have that quadratic. And again, if you need a review on factoring, make sure you go and watch the factoring videos. So on the numerator, I still have n plus 1. I can drop the brackets because I'm not multiplying anything through anymore. And then in the denominator, I'm looking for two numbers that multiply to negative 8 but add to positive 7. So that would be negative 1 and 8 plus 7n over n plus 8. Oops, I somehow changed to x's instead of n's. I don't know why I did that. Okay, make sure you keep your variables consistent all the way through. So anyways, should have n's. Now I'm going to make a common denominator. I factored everything as much as I can, so I'll make a common denominator to bring these two rational expressions together. So I see here that I have an n minus 1, an n plus 8, and an n plus 8. So my common denominator then, when I bring them together, will be comprised of, I only need to bring one of those n plus 8, because it's already common in both, and then I also need the n minus 1. So the first part here, this n plus 1, was already over what is my common denominator, so it can just stay the same. And then plus 7n times, well, it was only over n plus 8, so I need to multiply it by n minus 1 to keep this equivalent. So again, to finish this off, I should multiply this through here. So I'll have n plus 1 plus 7n squared minus 7n all over n plus 8 n minus 1, and then I should collect my like terms. So running out of room here, going up here, I'll have 7n squared minus 6n plus 1 over n plus 8 n minus 1. Okay, and then again I should look, can I factor? I do see I have a quadratic on the top again in the numerator, so can I factor that? So I'd be looking for two numbers that multiply to 7, but positive 7, but add to negative 6. So the only way I could do that is with negative 7 and negative 1, or positive, so that would multiply to positive 7, or I can't do it. I can't factor that. So that's actually as simplified as it gets. So you should always look to check to see if you can factor, because you might be able to cancel out more stuff within the denominator. But in this case, you can't, so that's the final answer here, the most simplified version. And then I should also state my non-permissible values, so this is okay as long as n is not equal to. So going back to the beginning here, or where I factored, I canceled out that 5, it doesn't matter because I didn't have a variable in it. So I can kind of go back to this stage here. And I see that this is okay so long as n is not equal to 1 or negative 8. So I don't have to repeat the negative 8, I just have to list it once. Okay, that's it. Thanks for watching. Good luck with the assignments.